Hello, welcome back to another episode of the Reliability Gang podcast. And this week we have a very special guest. I'd like to welcome to the show Mark Gurney. How are you keeping, Mark?
Yeah, well, and thanks very much for the invite.
This is crazy that we're actually doing this. Mark has been here all week, and seems like you've been here for a while, isn't it, Mark?
Yeah, well, quite a few days.
He's been solving a lot of problems.
Yeah.
I think because he's solved so many problems, it feels like we've been here just for longer than we actually have been.
Yeah. So we've had 2 days on site.
Yeah.
At a biogas plant, and yesterday we had a full day of classroom work.
Very enlightening day, let's say the least. But yeah, no, Mark has kindly come down. We've wanted to do training with you, Mark, for quite a long time, to be honest. And it's always been something that we and Will have always said, we've got to get Mark down. We've got to do some training. We've got to try to understand these problems that we're seeing because, you know, Mark pulled up and you see a big box of bearings all with electrical fluting in them. And this is one thing we've been experiencing just for such a long time. And it's such a high percentage of failure modes we're finding with it. And when, obviously, before I kind of knew of, I've always known of Mark on LinkedIn. I've always seen your posts and everything. But when I started first seeing shaft current a while back, whenever we seeked information, I don't know how I didn't come across you, Mark, but it was such a shame because when we're trying to find the solutions, there wasn't really a solution out there at the time. And you know, we just
I think it's there's a lack of knowledge generally in industry of why it happens, and you've got to build up that experience of trying different things and then eventually you'll work it out on what makes it
100%
flute a bearing. But it's not just the bearing.
There's so much.
I mean, the electrical discharges you get from an inverter, they'll attack your lubrication, and often that'll go black. But also what a lot of people forget is that it's attacking your motor
windings.
The winding of the motor.
Well, why is that, Mark? We just forget the windings all the time, don't we? We're always so laser focused on mechanical bearings. And why do we forget the winding all the time?
Well, a lot of VA people are mechanically based.
I think so, yeah, you're right.
There's not too many electrical fellas around.
But it's so true what Mark is saying because, we have... Of course, and it's very important to understand all the failure modes. But when we actually do look at reliability, we look at failure modes. One of the very big failure mode of electric motor is this winding. So why are we not really treating condition monitoring in the same way on them as opposed to the mechanical parts?
I think electrical professionals tend to get left behind a little bit in condition based maintenance. When a motor fails, they get their mega out and they get the resistance multimeter out, and they're the only two tests that they tend to use.
I know, because such a common thing in a electrician's toolbox to say, "Oh, I've tested the motor," and it's like, "Well, what have you done?" "Oh, I've measured it." They say, "Oh, I've measured it," and that basically means an insulation resistance test, really, doesn't it? That is it.
And I mean that test is only going to show you that the motor's failed, or very, very close, So it's very unlikely that many electricians will trend it over time. It's usually pull it out when a motor stops, and they just confirm that the motor's now not working.
Oh, Mark. When did you start, Mark? So obviously we had a great conversation over dinner the other night, didn't we? It was really nice, actually, really kind of, I think for me, one thing I love about the reliability game is learning people's journeys, like where they started, and as well as someone who's had so much experience as well, from that conversation, and also some of the real early days, the win days when, you kind of turn around a lot of operations and really started to get involved as well. And one thing I didn't know is your involvement with ARP and a lot of the reliability stuff. There's so much I didn't know about, Mark, I think. And I think the beautiful thing about that dinner was there was just so much more to it than just the guy that sold bearing currents. There was a whole reliability piece. Where did it start for you then? And then I'd love the people to hear about that story a little bit in a short form, you know, because that was a cool story.
Yeah, well, right out of uni, I got involved with maintenance, and you know, it's been sort of in the blood all the time.
It's always been there, yeah.
But where the opportunity came was when I joined a dairy company in Australia. We had quite a few sites, and had a support of our CEO to increase our reliability, because it makes a big impact on the business and the profitability.
Yeah.
I got teamed up with two other gentlemen, one who was concentrating mainly on quality and another one on operations. So they were the elements of OEE.
It's having everyone together around the process, isn't it?
So, I mean, we actually developed a reliability program that looked at planning and scheduling, you know, how to do sort of basic FAMICA analysis and get your PMs going. And we included obviously CM in that as well. And, you know, like being a young engineer at the time, you make a lot of mistakes, but
that's the beautiful thing, though, isn't it? You learn from them, don't you?
Yeah. But then generally, you know, we were kicking goals, and we had the real good support from ours.
You had a good team, didn't you? You were saying you had a couple of you guys that, like, it was great that you was on board with it and you loved it, but you also had a few people around you that shared the same passion, didn't you?
Yeah. Well, you see, we had it was quite a large company, but because everyone was pulling their weight, you had a lot of support. Some of our maintenance guys at the sites were just so good.
I know, and I think one of the things I loved about your story was how you, as a team, did it as well, and how important as well, even in ARP, when you start to do that course and you start to understand the principles around it, how important it is to have people on board. And I think you said one thing really, really crucial, and I really remember it when you said it, is that when you got the people together and they had the same passion, it just worked. It just clicked.
Yeah. So what we did is, and I think I explained it to you the other day, is that we took an electrician and a fitter pretty well much off the tools, but told them not to be part of the reactive maintenance.
Yeah.
So they were there to look at the downtime, look at, you know, the top 10 bad actors, and have these little projects that made a difference.
Yeah, so that's kind of the reliability part coming, isn't it? You know.
Yeah, and then we would get all those sites together, and they would share those experiences.
It's like a master networking with engineers, isn't it? Yeah.
Yeah, and what happened is that sort of snowballed, and it really made quite a big difference. And it also made my job very easy.
Yeah, but that's what I think really kind of struck me, because he said, well, I just had to get everyone together, and they did it. They just did cracked on.
I mean, I ended up paying the hotel bills and the beer and the food.
It's small price to pay, to be fair, though, and it's a small price to pay, when you're trying to win the fight for reliability in your plant. And
so what happened was, one of the very common projects across those sites was about motors, because they're the lifeblood of industry.
Yeah.
They also use, you know, close on 3/4 of your energy bill.
It's just phenomenal, isn't it?
On electrical energy. And it's such a big area that can make a huge amount of inroads.
Yeah, 100%. I mean, when I think just even what you said there with being such a huge part of all of our lives.
Yeah.
Like you look at manufacturing and you look at kind of the impact of what an electric motor does. It drives absolutely everything on that site, you know, whether it's a pump or a gearbox or whatever, you have an electric motor that is pulling that industry to where it needs to be. So I think when you start to explain what motor management, you know, your practice is, it was a bit like, why have we been overlooking this for so long? But also, why have I never thought of it in the way that you have, in terms of okay, don't get me wrong, we're doing electrical tests with some of the equipment that we have, but we're not going into the same depth and detail as we would do if we was doing vibration analysis.
Yeah.
And it's also really important to understand all of the failure modes. And we at Maintain Reliability have been really conscious about that the last few years, rather than just trying to do vibration analysis on everything, is look at, you know, the reliability and what are the other failure modes? What other technologies can we use to be able to really improve what we're doing? And, you know, this week's training for me has been such an eye-opener that we can be empowered as well to test for things in a process-driven way that allows us also to get to the solution fairly quickly if we can have access to that equipment. You know, this week training has been incredible, by the way. It's been amazing. I appreciate you coming down.
And probably one other point is that we developed an overhaul specification and a new purchase specification for electric motors. It's amazing how many defects that you're actually purchasing. And we were fortunate enough to bring Howard Penrose over from the US, I think twice.
Wow.
And he helped us develop that overhaul and purchase specification. So that now is part of best practice motor management.
Yeah. And that's what you're driving, isn't it? That's what you're teaching us as well.
Yeah. And so all the end users that we get involved with, they have the free access to all that
information,
that knowledge and procedures and be able to not make the mistakes that we did.
Yeah.
And so that you can come up to speed a lot quicker.
And I love that, because I think that's also one thing that, you know, I started Maintain in 2017, roughly. And at the start of the journey was difficult because not everyone will want to share information. There's a lot of people out there as well that want to keep a lot of the stuff they've learned to themselves. And one thing Mark's done this week as well, which I'm very grateful for, it's not just the fact, of course, you know, we've paid for him to come down. Of course, we have to learn from him, but it's his willingness to give more than that. There's a legacy thing there with Mark, where it is true though, isn't it?
Yeah.
There's a legacy there, and there's something that drives him to say years and years, this motor management procedures forever is going to be something that can potentially be ingrained in the industry. And if we follow that better practice, look how much better reliability can be for forever, you know, moving from that point. It's a legacy thing when it comes down to it. It's something that what you're doing there has a huge effect for many generations to come with that just philosophy of maintenance and the way you do things, you know. So,
I mean, I presented at Mobius Manchester, when was it? May last year.
Yeah, Will was there, wasn't he? Yeah, I think.
And I got people to all stand up. And then I asked a few mechanically minded sit down. And then we started with about 130 odd people in the room. So the mechanical guys sat down. And then I said, if you've got an electrical license, so you can actually do some work on electrical work.
Stand up.
No, I said remain standing.
Oh, okay. And both,
we ended up with 5 people.
That's crazy. But what is that? I've found that in industry where even when we was growing up, you was either very electrical or you was mechanical.
Yeah.
And if you was mechanical, you did not understand electrical. And if you was electrical, you wouldn't be able to get the other.
The problem is that condition-based maintenance industry, you know, be it vibration or ultrasonics or thermography or whatever it is very much mechanically biased.
I agree. Yeah.
And you said about, you know, the willingness of sharing information. Well, the problem is that there's such few electrically based reliability professionals.
Yeah,
and the problems are huge.
I know, and there's only one of you.
so it's a big pond with a little fish.
Yeah, I know. I see that.
So I'm not in a position where I need to hold on to that information because even if I spread it everywhere,
I've still got
to be busy. So it doesn't matter.
100%. But I love that as well, because, you know, like the whole and that's the thing through the training, we went through the philosophy of motor management, understanding good spare practice, understand where we keep spares, understanding, you know, lots of different things. It wasn't just how we test a motor and how do we test for certain shaft current. It's a philosophy. And I think, you know, guys, check out, you've got blogs on this, haven't you?
And also if people Google just 3 PHI reliability, I think I'm on the top list, which is really nice, of Google. And then if you follow you through to the blog, there's a whole heap of articles.
So much information, yeah. So lots of content for you guys to go have a look at, and have a look at as well the motor management side of things, because I could probably do 20 podcasts here with Mark today, but we've only got an hour. So we've actually had to have an itinerary before what we're going to talk about, because at dinner we was talking for 2-3 hours straight, and like there was a lot more to say. So obviously go check that out, but also go check out the motor management side of it all, the whole part, not just the little bit of testing, not all of that. Look at the whole thing, because when you look at our industry, I don't think this is done enough. And I think, you know, this is something that we've got to shout about. And we at Maintain Reliability want to shout about this now as well, because, you know, we're partnering up with Mark. You know, he's going to be a mentor for us now. Do you know what I mean? We've done the training, we're going to get some equipment, and, you know, just it doesn't stop after you don't stop learning from one training session. Like,
now there's going to be a million questions.
Exactly, it's gonna, and I'm already like excited to get this kit. I've already ordered it. It's crazy. I was last night. I was in my basket. I'm like, oh yeah, I'll have that. I need that. I need one of them.
Yeah, but you know, it's not just about the different tools of being able to go out and use that instrument to find that fault. I mean, there's some simple stuff. I mean, we talked a bit about grease caps.
Yeah, right? I know. Simple little things like grease caps, you know.
I mean, I've been in the UK now over the last year quite a lot.
And he's basically been there half the time.
So I've not been to a company where that cleanliness and wiping down the grease nipples, and putting a new grease cap on, because I mean, when you do that, you look professional.
I agree.
And that changes mindset. It improves the culture. So it's these little things. You know, how you store your motors.
Yeah, 100%.
Okay, we talked about putting silica gel packs in the terminal boxes.
Great idea.
And taping them up.
Because that's the thing, because like we was talking about it, and it's humidity that draws into your motors that kills them. And that's what we was talking about as well, with like regulation of humidity. And just by putting a silica gel patch, you know, they're incredible little things, aren't they?
But you go into a motor store and you see, you know, all the cable entries are all open.
Yeah, and
they haven't got the plugs in.
It's crazy, little things, isn't it? So, and they're the things as well, because, you know, we talk about insulation resistance with motors, and when you've got a motor that is low to earth, they can be extremely horrible defects. And
well, I can give you an example. I went to a very big manufacturing plant in France last year, and we started testing motors in their store, and it was a massive store.
Really?
It was a steel mill. So it was
lots of motors all queued up, ready to go.
And we were testing, and we were getting dissipation factor, or contamination, in other words, moisture, in the motors. And then we found one that was good. And I said, "What's going on?" And my host says, "Oh yeah, that's only been here a few weeks." So I hadn't had time to suck in the moisture.
Yeah, and that's the thing. Like, just something as simple as that can be so detrimental.
Yeah,
you know.
I mean, the motor will still run.
Yeah.
But the problem is that when that insulation gets saturated, it's not good for the long-term reliability.
It will just start to wear away over time, won't it?
Yeah. So you've got to keep.
There's a reason why we have the standards, isn't it, in keeping insulation.
Well, there's no probably real standard. There's just some.
Very high numbers,
Best practice.
But management best practice. We're going to talk about that a lot today as well. So, this week, you know, it's been incredible training, and let's go over some of the training stuff that we did. So it was Monday, Mark come over, and we did some testing at a biogas site, didn't we?
Yeah.
Right. Yeah. We had a very big addy compressor, and these are extremely important for the industry. I mean, basically that addy compressor is the one compressor that's compressing the gas and sending it away to grid. So if that does fail, the whole plant is kaput. It's down. Yeah. It's down. Mm-hmm. So we went over there, and there was quite a big whine on that particular motor. It always has been for a while, wasn't it?
Yeah, it's got that real inverter high pitch.
You hear that pitch, yeah. Horrible pitch.
So I mean, it wasn't a good install. There's not screen cables. We got the SKF Tech Ed pen out, and it was the counts were pretty high.
Well, high, yeah. They were, yeah.
So we were really behind the 8 ball on that one to start off with. But what happened? It got changed, I think, New Year's Day, right? So we're now only a month or so.
Yeah, we're just into February, aren't we? So about 1 month and a week, yeah.
And what happened was the one of the external earths, when we had a look, was just flapping in the breeze. So, but you could see where it had been, but it had been on a painted surface. So even if we had attached the earth back, it wouldn't have done anything.
Yeah.
So we got the emery paper out and rubbed the paint back to bare metal, cleaned it all up. We actually used a little bit of
what do you call that? You showed
conductive
grease, yeah.
And I've done some testing, and that reduces resistance by at least half again.
Wow!
So
just by using some paste, it's crazy.
So we put that earth on. There was a couple of connections in the actual motor terminal box which were loose, probably wouldn't have helped. Then we obviously did some testing, took some live data of current. And then we fired that back up, and you could actually hear
the pitch changed.
Yeah, the audible change in the motor was completely different.
And it's weird because when you get that really high, horrible pitch, but then it's not sometimes a noise, it's how the tone changes. It was so noticeably different on that first one.
Yep.
And that's the really interesting part, because straight away you could tell what we'd done had made something better.
Yeah.
Straight away, without even the test.
So you've got to remember, audible, the switching speed on that was about 5 kilohertz.
So very high frequency, yeah.
Well, you can hear that very easily. It's actually in the area where it's actually quite nasty for your ears.
Yeah, and that's why it was horrible.
But then you can get the second and third order of those
frequencies
because they resonate. So the second order is going to be 10,000, then 15,000. I mean, your hearing's good for what?
What did they say is your hearing?
20,000.
20,000.
If you're not an old fella.
All depends.
But so that you can actually walk past a motor and you can actually hear a lot of that inverter.
Yeah, so that's obviously the audible range. And you're right, it's like an unpleasant area where your eardrums start to resonate at a point which is uncomfortable.
So by fixing up that earth, that noise effectively got attenuated. Now, earthing is probably the number one factor in controlling bearing currents.
It's crazy,
it's people jump to all sorts of different what I call band-aids, and don't address the root cause.
And that's the problem, isn't it? Because that is inherently what we're seeing in the industry right now is people doing things without the right data and information. Okay. We can't be going back to, it's almost like schedule-based maintenance where you're just doing something for the sake of it without really basing it on information. And this is another issue and problem that we have had with the shaft grounding industry. I mean, we've seen it as well, where a lot of companies are out there just saying that this solution will solve everything, which is a lie. Because when we've done our training this week, and we've also understood and realized this as well for a while, without really the real understanding after Mark has given us did the kind of, and it's crazy because without Mark's training this week, we'd have been so much less wiser about the situation. But once we've learned about it, it's almost quite, it's not obvious, but it's quite, a lot of it makes so much sense just from the earthing's perspective of things.
Yep.
So it's like we're almost in this kind of scenario right now within the industry where Mark has this knowledge. He has the solution to a lot of what's happening here, but it's not rocket science. That's what he said. But there's a process way that we also have to understand what we're looking for, just like we would troubleshoot a machine when we're trying to do vibration analysis on it. But what he's saying is, like, let's go through the process. Let's look at its fundamentals first, you know?
I mean, on the subject of bearing currents, the issue is that they come in different types. And until you measure, you don't know what type you have.
Yep.
And sometimes, or most times, you will have a combination of those.
Yeah, exactly.
So, you know, you take an insulated bearing that's designed to stop circulating current.
Yeah.
And it's only one type. And you've got different mitigation strategies for the different types of bearing current.
And that's the thing. Even on LinkedIn, when everyone's like, put an insulated bearing on it, it's like, no. So it might not be a circulating current, you know?
So, so you've got to be very, very careful of what you select, but measure first.
Yeah, 100%.
Yeah.
So we're now onto the testing side. And this is, for me, this was a really fun part, I think, of this training, just looking at Mark's equipment. Oh, that's a cool machine. What does that do? Oh, that's measuring something. And, know, I think, as you know, us, we love, I've used a lot of vibration analysis equipment in the past and all the gadgets and the toys. But all this was kind of like, it looked all very data collectory, but it was very different in the way that it kind of, so, you know, we've got a range full of tools. I'd love you to go through your tool sets. What's in Mark's tool bag?
Well, there's some really nice stuff in there. You know, like we got motor
stuff as well.
Yeah, but also probably the single best one is just the Rogowski coil.
Yeah, just such a simple concept.
And an oscilloscope.
That was great, yeah.
So very, very cheap pieces of equipment, and they can help you solve a lot of problems.
Yeah, because like, what was the oscilloscope? It was a plug-in one to your computer, wasn't it?
Yeah, I just use a USB one that plugs into my laptop.
And it was probably one of the best things I've ever seen. We've had all these other oscilloscopes for this shaft grounding equipment. We've got the fluke scope meter, but nothing beats on the computer screen seeing that window. It's so easy to read, really easy to put together, really easy to scale between what you want to see. It wasn't cumbersome and all done on your computer. You know, it's great.
And it's Ryanair friendly.
Yeah.
Because it goes straight on.
It's so exactly. Bag. But that's the thing as well, Mark. What people don't consider, it's like if you're going to go traveling with this equipment, how do you keep it as well really small?
Yep.
So that's another whole device that you wouldn't necessarily have to bring because you've already got your laptop, and I think it was brilliant. I love that oscilloscope. Really, we've already ordered one, so you know.
So it's by taking the measurement with a Rogowski coil with a scope, you can pretty well much determine what type of bearing current you've got.
So why is it important as well? And this, I think, is something really important to know. Obviously, Rogowski coil testing opposed to shaft voltage testing.
Yeah.
Why is it better to do current tests with a Rogowski coil opposed to trying to take a reading off the shaft? We've seen a lot of these shaft like devices, and inherently we've used quite a few, and they've always seemed a little bit unstable, if I'm honest. You know, once I saw your test the other day, looked very stable in terms of readings, very easy to see the stability in what we was getting current wise. But whenever we've tested with like on the shaft, it's been a little bit subjective, if I'm honest. It's been a bit up, bit down, bit difficult to really kind of average out, you know.
Yeah. I asked a question. The subject's called bearing current.
Yeah.
So we measure current.
Yeah. 100% love that. And that's the thing. With all these other people trying to push devices as well, you know.
And the problem is that, don't get me wrong, the shaft voltage is a good indicator.
Yeah.
But it's also dependent on lubrication quality.
Okay, of course.
So if you've freshly greased a bearing and you take shaft voltage, you're going to get a different reading than if it's dry.
Dry, yeah. Obviously interesting, yeah.
So you've got to keep that in mind. Whereas if you measure the bearing current, straight off the bottom of the inverter, then you're getting a good reading.
Yeah, 100%. We see that. We generally see that. So I remember seeing it on the oscilloscope, and it was very clear.
Yeah.
And it was very clear as well after we'd done some earthing afterwards, the difference that we was finding within the stray currents was actually phenomenal.
I mean, I've just, late last year, we did a bit of a tour through Bulgaria and those other nearby countries, and we actually were measuring peak to peak common mode current or bearing current, versus the lubrication condition. And what we found there is that when you get optimum lubrication and using SDT ultrasonics, there's the plug.
Love it.
Well, what happens is that when you get optimum lubrication conditions, your common mode current drops.
Yeah, of course. Yeah, you're saying
so it's there's quite a lot of factors involved.
There is, and that's the thing as well about poor lube. I mean, how many times as well with a couple of the case studies I showed Mark as well. One being when they over lubricated but mixed the two different thickeners of lithium and polyurea, how quickly the shaft current destroyed the bearing from that was phenomenal.
I mean, it's probably it would have had an effect probably on the lubrication film. And once you get that metal on metal contact,
it's you got, aren't you?
Well, then you've got a conductive surface.
Yeah, and it's going to really accelerate the wear in the bearing. And this is also why, obviously it's great to understand kind of your motor testing and what you're finding, but even more importantly, the proactive nature of really doing lubrication properly. And this is another thing as well, which is another simple one, which a lot of people don't realize that, poor lubrication is everywhere. We see it at so many different places still. And it's another proactive measure as well that has a huge effect on shaft current as well. And we're seeing that, massively. Well, we had one site where they have service agreements with compressor companies, for example, but they put self-greasers on these motors and they completely overclocked them. And the effect that had on the majority of these drives, even where we went, we see that, do you know what I mean? And they've taken them off now. But the problem is at the time, the damage was so quick to occur because of this combination of having really poor earthing and really over lubricating the bearing. And them two things together were taking bearings out very quickly. You're talking, 0 to 6 months, in terms of having to intervene on the maintenance side. It's crazy, isn't it?
There's quite a number of factors that make a bearing prone to bearing fluting. I quite like reading and sharing. There was a paper put out October 23 by Darmstadt University.
Is that the document you showed us? The other day.
And there's quite a nice list of dominant factors that affect bearing fluting, and it's a damn good read.
I think I'm going to read that one. That's going to be a nice bedtime.
And,
you know what I mean?
And effectively, the experiences that we've had with getting the low impedance earth from a motor, and taking away that bearing current to earth through the motor frame and not down through the rotor. Really, that research really reinforces what we've learned.
And what you taught as well, theory-wise as well.
Hands-on. So.
Yeah, definitely. And even the theory stuff as well. I mean, I did a HND in electrical and electronic engineering, but I went into winding motors, which was great. But then I went into this mechanical kind of world. So a lot of what Mark was saying was like ringing back in my old days, really, when I was back at college and understanding a lot of electrical principles, actually. And I think this is why I've enjoyed it so much, actually.
Yeah.
I really think I was destined to be an electrical engineer, and I went into mechanical, and now I'm coming back around the other way. But it's always nice to know both. But this is, I think, as well, we talked about this as well, didn't we? The lack of knowledge of having engineers that can do both and really understand, because Mark is, for me, is someone who understands both very well. But it also makes him a beast when it comes down to trying to find problems, because he's looking at the full palette. He's looking at the full spectrum of problems, as opposed to just maybe half of them. So I think this is as well, what the industry needs. We need more people that are able to tap into both sides, really, aren't we? And understand principles and failure modes on electrical sides and mechanical. Because if we can get them two people right, the future of the industry looks a lot brighter, doesn't it?
Oh, yeah, for sure. Yeah. I mean, I was fortunate that when I did my engineering, we had both mechanical, electrical.
Was it like a split 50-50 then?
And instrumentation.
Nice, yeah. Because usually one of the three, really, isn't it? Because you've got the control instrumentation side as well. But to be able to have all three sides of that was probably a really good apprenticeship. Yeah, wow.
So, it was a good grounding. It's probably one of the best decisions I made.
I can imagine
early on.
Yeah, definitely. Yeah, because I don't think people get too exposed to. I mean, again, when it comes down to electrical and mechanical, it's quite funny because you go to site and you've got electrical teams and mechanical teams, and they have so much banter with each other because they don't understand each other. And it's true, like
you almost get. I've been in situations where the problem has been electrical, and then the mechanical guys go. Because now it's not their problem.
Exactly. Then you get Mark's like, well, I'll solve either. You know what I mean? Love it. Absolutely love it. No, that's great. So this week we've been, obviously, we was training on Monday. We did some kind of some good theory in the practice. But one thing I really loved about the training this week was the theory and the practical, and even in the classroom side of taking some of the results, seeing them on the screen and seeing what the difference and what we did as well. Do you know what I mean?
Yeah.
So the training side, I think for you is something. How long have you kind of really been doing the train? Is it obviously it's picked up quite a lot now, hasn't it? The last few years for you, it's really started to take off, isn't it?
Yeah, I mean, I've done a number of these types of sessions for people, and I've got a few more next week.
Yeah, he's got a lot booked for this year as well. I think we're going to get Mark down again for a customer up north, because that's going to be really interesting one. Plenty of great things to teach them and our northern team, because they couldn't be with us this week, but they'll be able to jump on that. But I think the training of this is really where the beauty is now, isn't it?
And you've got to realise that I'm still learning.
Yeah, and that's the thing.
And every time I go to a site, I learn something different, and then I add that to the training.
Love it. It's just an ongoing. And that's what will happen next time I go on Mark's training or whatever. But that's a new added little bit, and that will be good. But
I know that picture.
Yeah, that's me. That's the case study that we did. But that's the beautiful thing about it as well, that the training consists of finding problems and solving them.
Yeah.
So what I do love about that, it's not just, I've got some training, I'm in a classroom, here's some examples. It's no, we're doing it. Yeah. We're solving one of these today.
Yeah.
And, for the biogas site we went to, we've massively reduced the shaft current on both of them assets. Do you know what I mean? By a considerable amount.
Yeah.
Huge amount.
Yeah.
And these two assets were getting severely fluid, and it's amazing. I'm just so happy that as well we solved the problem for the customer.
But there's another issue there, is that we haven't finished the job.
Yeah, there's still some bits to do.
So, we had some EMC glands that were grounding the screen to the motor. And unfortunately, they've used some that have got like a plastic insert, and they haven't been installed properly. So that means that the screen was floating at the motor end.
Yeah, okay.
So it doesn't really matter how much external earth or the PEs paint that we rubbed off. We got to change the glands and get them installed properly.
Yeah, get some connection.
And I'm very, very confident that after that gets done, that the bearing common mode current will drop to very, very low,
minimal levels. Yeah. And that's crazy, because these, the bearings are going to probably input in the video now, because we've got these bearings. This was the damage on the bearings. It was crazy. It was so destructive. And, this is, we're just excited now to as well, because we also understand that we're not overnight we're going to become bearing current experts, But one thing that we are doing with Mark is he's going to mentor us through this. There's going to be a few troubleshooting things out in the field. We've even talked about getting some fancy glasses, like in the field glasses and stuff like that, which is so cool.
So, I have used and I've got a pair of AR glasses. They have a little computer screen in front of one of your eyes. But what it means is that someone that's solving a problem, they dial in, voice activated with Microsoft Teams.
And Mark can see everything.
And I see what they see.
You can annotate on there as well, and all sorts of cool stuff as well.
So you can coach people.
Yeah.
And I've done this, I had a client in New York State, and I was sitting in my office in France. Yes, the time difference was not nice, but we were able to instruct them virtually.
I love that. And that's where we need to go. We got to use technology to be able to, because knowledge is there. Yep. It's just about the application of it, and how do you help people from afar, and this is what we got to lean into. This is new technology that we've got to, and I just found that pretty cool. Like now it's about, doesn't matter where you are in the world, you've got the knowledge pool out there to be able to support, and Mark supporting on the other end of the world is a cool thing.
And it's not too bad for an old fella to get into that technology.
I love that though as well. He embraces this technology like all us do, we've he's definitely a part of the reliability gang on that sense in terms of technology, 100%. We totally advocate for that as well. So, Mark, it's been an incredible week, and honestly, I can't thank you enough for coming down and enlightening us all. Do you know what I mean? It's been honestly, I'm actually sad to see him go. I wish he could stay a little bit longer, but there's a lot more problems for us to be able to go out and go solve and everything like that. But Mark, I'd like to thank you so much for jumping on the podcast. We've had just a good 40-minute session.
Yeah, wow, 40 minutes. Yeah, wow.
Plenty. I know. I don't even know where that time's gone. It does not feel like I've been talking for 40 minutes at all. Yeah. We try to keep them to 30 minutes, but let's be honest, it's a bit of a special occasion really when you come in to have a chat. But yeah, we'll definitely get Mark on a part 2. I think when you next come over down here, we can maybe dive a little bit deeper into like more of the shaft current stuff a little bit. I don't want to get too deep today. We can give them a little bit more, give them a bit of a teaser so they can come and join in a little bit later. But Mark, I'd like to thank you for joining this week, and thanks for being on the show, buddy.
Yeah, well, thank you very much. Yeah, that's awesome.
Take care, guys.